So our fundamental trig identities are our most basic trig identities. There's actually a super long list of all different types of trig identities. We're only going to pick out a few today to talk about. We're going to talk about a few next class, but we're really only going to use the ones that primarily show up in calculus. There are a bunch of other ones, but we're going to just use the necessary ones so that you're prepared for calculus next year. The whole reason that we do these is they help us simplify expressions, they help us solve equations that are maybe written in multiple trig functions, and they can even help us kind of redefine complicated transformations if we're graphing so that we can make the graphs a little bit simpler, because we've seen so many things repeat when we're talking about trig that we actually have rules that allow us to substitute in, simplify, just make things prettier so that we can make it easier for us to solve. So we primarily are going to use these, especially today, just to simplify expressions, just to get used to them. So we can use them to simplify. We can use them to solve equations, and we saw that a little bit with that Mr. Math Head. You saw him, I rewrote him for you, but we can exchange trig functions for other trig functions to make it easier to solve equations. And we can redefine complicated transformations, so that helps us when we're graphing. And there is a beautiful color-coded copy of all the rules that I'm going to give you, typed up nice and neat and linked in the bottom right corner of every virtual classroom that you have. So it's like directly across the chalkboard from the unit circle. So where you could pull up your unit circle in every virtual classroom, there's one that says Trig Identities that has a beautiful list that's all color-coded and pretty for you. So you can always go back and reference it there if you need it. So the first 6 rules you actually already know. There are fundamental identities. They can also be referred to as our reciprocal identities. So when we're talking about these identities, we can go in and anytime we see a sign of x in a function, we can rewrite it as 1 over cosecant of x. So the first 6 you've already seen, because we've used these the entire time we've talked about cosecant, secant, and cotangent. It just is actually an official way for us to switch out things when we see them so that we can make it easier to solve. Cosine is 1 over secant. Tangent is 1 over cotangent. Cosecant is 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. So these are just our rules that we can use to plug in. So sometimes it might be helpful for us to actually change sine into cosecant, because then maybe we can change and cancel out a cosecant somewhere else, or we need to get cotangent to be tangent, so we can kind of flip-flop them back and forth using these rules. So then the next 2 that we can use that are very similar to this are our trig ratios. So we know from our unit circle that tangent of x is the same thing as y over x. And we also know that our y value on the unit circle is our sine value, and our x value is our cosine value. So anytime we see tangent, we can replace it with sine of x over cosine of x. So anytime we see tangent, we can make it sine of x over cosine of x, or anytime we see sine of x divided by cosine of x, if we don't want that fraction in there, we can change it to be tangent, because we know tangent is y over x, we know sine is y, cosine is x. We also know that cotangent is our reciprocal of tangent. So if you saw cosine of x over sine, if it was just the reverse, then they're talking about cotangent. And the more practice problems we do with these, the more that you work with these trig ratios and the more familiar you are with them, the easier it's going to be for you to start to pick out when they're helpful for you to use. So the first couple, it's going to be super uncomfortable and you're going to be like, okay, lady, what the heck? Why are we doing this? But it's going to help us super simplify things. Like a lot of times we can simplify things down to one trig function, or we can simplify it down to just be one solid number, and it just makes our lives so much easier moving forward. So then these are the last three that I was talking about that I put separate videos in your notes if you want to go back and watch the proofs of why these exist and why these identities are real things. There are separate videos for you to watch in the notes if you want to know that. If you just believe in me and you trust me, you will be able to do just as much just knowing these rules. So our man Pythagorean hooked us up with a squared plus b squared equals c squared. From that, if we bring in our good old unit circle and our values of trig functions, we can also get that sine squared x plus cosine squared x, so similar to a squared plus b squared, equals c squared, which in this situation, our hypotenuse, anytime we're on the unit circle, is 1, and 1 squared is just 1. So sine squared x plus cosine squared x is the same thing as 1. This is probably the most common Pythagorean identity that you will see, especially in calculus next year, especially if you take AP Calc next year. This is the one that pops up the most, but we do have two other ones. We can also say that 1 plus tangent squared x equals secant squared x. And we can say 1 plus cotangent squared x equals cosecant squared x. Now the cool thing about these is I don't have to just see sine squared plus cosine squared in order to substitute in a 1. But anytime I do see sine squared plus cosine squared, I can replace it with a 1 since they're the same thing. But if I was just feeling wild and crazy and wanted to move this sine squared over to the other side, I could manipulate this identity so that I end up having cosine squared x equals 1 minus sine squared x. So anytime you see cosine squared, you could also rewrite it as 1 minus sine squared, or if you saw 1 minus sine squared, you could change it to be cosine squared. I could have done the same thing and moved cosine to the other side, which would have given me that sine squared equals 1 minus cosine squared x. So those variations of the identity can show up and help us simplify things too. So I would definitely make sure you had those written down, because those are not on that color-coded sheet, because the color-coded sheet expects that you know how to add and subtract things to other sides of equations and manipulate equations like that. I could do the same thing with number 2 and number 3, where I could get tangent all by itself by subtracting 1 on both sides. So I could also say that tangent squared x equals secant squared x minus 1. Or I could get cotangent by itself and say, okay, cotangent squared x equals cosecant squared x minus 1. And right now this probably just looks like a whole bunch of crazy trig nonsense to you, but we're going to do some practice problems where you'll see that by using these I can make what is one heck of a monstrosity into just one trig function or just one number. Everything you've ever dreamed of for a Friday, last period, right? Every dream has come true at this moment. All right, so can I slide this up, or am I getting too excited and I need to slow down? When you're going to start these, the first thing is I promise that it's going to seem super overwhelming at first because I just dropped a whole bunch of new rules on you. But the more we use the identities and the more they just kind of get stuck in your brain, the faster and the easier these problems are going to become. Because as soon as you remember that anytime you see tangent, you can rewrite it as sine over cosine, life's going to get better. So the more familiar we are with them, the more we use them, the better this is going to get. The other thing that you always want to try and do is when you first look at these problems, we want to try and get everything to be sine or to be cosine. It'll just make our lives so much easier to simplify. Because we're used to sine, we're used to cosine. So if we can, change things to be sine, change them to be cosine, and then simplify. Alright, so without further ado, let's see what these bad boys actually look like. We want to take something like sine of x, secant of x, all over tangent of x, and we want to simplify it as much as possible. So, fractions, trig functions, all smushed into one. It's basically like the big mamma jamma of math problems. A little overwhelming. We want to make it look prettier. So since I start with a sine of x, I want everything to be sine and I want everything to be cosine if possible, because that'll make it easier for me to cancel things out. So I'm going to leave that sine of x alone, but I see I've got a secant and I've got a tangent that I can rewrite. It doesn't matter which one I pick first. There's definitely different avenues that we can kind of take to all get to the same answer. It's more of your personal preference. Normally I just kind of start on the top and then work along, but whatever you see first, you can change first in this situation, because multiplication and division, there's no order of operations there. We can just kind of change things. So the first thing I want to change is I'm going to rewrite secant to be 1 over cosine, because we know secant is the reciprocal of cosine. So if I want to get secant to be sine or cosine, I can get it to be 1 over cosine. So I take my same problem, I take my sine of x, and instead of writing secant of x, now I'm going to write 1 over cosine of x all over tangent of x. If I have sine of x times 1 over cosine of x, it's really like I have these two fractions that are multiplying here, so I can multiply straight across, and I can simplify this. See, I'm going to move over so I have enough room. Sine of x over cosine of x. So I would multiply straight across. Sine of x times 1 just gives me sine of x. 1 times cosine of x gives me cosine of x. All over tangent still. So now I want to get everything to be sine and cosine. So I also want to change tangent. Tangent can be sine over cosine, right? So now I'm going to take my tangent, and instead of writing tangent, I'm going to write sine of x over cosine of x. So I'm going to bring the top of my fraction over. I'm still going to have sine of x over cosine of x. And now instead of writing tangent in my denominator, I know tangent is the same thing as sine of x over cosine of x. So I have two options at this point. I noticed right away that I have sine of x over cosine of x in my numerator, and I have sine of x over cosine of x in my denominator, which is exactly the same thing, right? My numerator and my denominator are the same thing, and I know when I have fractions that have the same numerator and denominator, they just simplify to be 1. So I could at this point just say, okay, the whole thing equals 1 if I recognize that. If I don't recognize it, if I don't really notice it, I'm going to say, okay, let's keep the top part, change the sign, and flip the bottom one, because that's what I would do anytime I was simplifying a fraction over a fraction, right? Keep, change, flip. So if I don't notice it, and I keep the top one, so I still have sine of x over cosine of x, I'm going to change my sign to multiplication, and I'm going to flip my bottom fraction to be cosine of x over sine of x. It makes it a little bit easier to see now that that's going to simplify to 1. Because now I can cross cancel, right, my cosines. I can cross cancel my sines. And this whole thing simplifies down to be just 1. So instead of sine of x times secant of x all over tangent of x, if I saw that in an equation, I could simplify that down, and I really just have a 1 there, which is a whole lot easier to work with than all that junk we started with, right? Let's try another one. So now we've got cotangent of x times secant of x all over cosecant. So nothing is written in terms of sine or cosine, so we can kind of pick and choose. There's no right or wrong place to start in this situation, because we just want to start changing things to be sines and cosines. We just want to make sure we don't do any like illegal math maneuvers and cross cancel things that we can't cancel. But we've got all multiplication here, so we're sitting in a pretty situation. Do you have a preference as to which one you want to change first? Do you see one and you're like, oh, I know I can rewrite this as 1 over cosine, or oh, I can rewrite this as cosine over sine? Do you see something you could change? The cotangent, right? So cotangent, I could rewrite it as 1 over tangent. That's 100% true, but it's not going to help me, right? I don't want tangents. I want sines and cosines. So I can take this cotangent, and I can rewrite cotangent to be cosine over sine. So instead of cotangent, now I'm going to have cosine of x over sine of x times, I still have my secant of x all over my cosecant of x. And I just want to keep changing things. So since we started in the numerator, let's keep going with the numerator. We'll simplify that as much as we can, and then we'll work with the denominator. Exactly. So now secant I can change to be 1 over cosine. So I end up, I'm going to keep my cosine of x over sine of x times, and now instead of writing secant, I can write 1 over cosine of x. And I haven't messed with my denominator, so that's all going to stay the same. Still a cosecant of x down there. And this is where we have options of different methods, and we may not all pick the same one when we're doing these on our own, because we could change the cosecant and then leave the simplifying for the end, or we can simplify the numerator and then change the cosecant. Personally, I like to kind of simplify as I go along so that, one, I'm not exhausting my hand by continuing to write extra stuff that I don't have to write, and two, so that it just makes the problem a little bit smaller and easier to work with and simplify later on. So I see cosine of x times 1 and sine of x times cosine in that numerator. I can cross cancel the cosines so that I really only have 1 over sine in my numerator. So now I'm just going to rewrite it. I really just have 1 over sine of x left in my numerator, all over cosecant of x in my denominator. So there's nothing I can simplify anymore in my numerator, so I'm going to rewrite cosecant of x. I'm going to rewrite cosecant of x to be 1 over sine of x. So when I do that, I'm going to keep my numerator as 1 over sine of x, all over my denominator is 1 over sine of x. Ooh, what do I see? They're the same, right? My numerator and my denominator are the same. So I could straight up just say equals 1 at this point if I recognize that this is the same as this, right? So it simplifies just to be 1. If I don't recognize that, I could keep the first fraction, change the sign to multiplication, and flip the second fraction so that now I see the signs cross cancel and I get 1. Kind of coming together. What if I gave you 1 minus sine squared theta over sine squared theta? So the first thing that everybody wants to do and gives me the heebie-jeebies is you cannot cancel those sine squareds. Even though there's a sine squared in the numerator and there's a sine squared in the denominator, you can't cross cancel like that from the numerator and the denominator unless there's a sine squared in every single term, because we have that minus sign in there. So because there's now a minus, we can't just start crossing things off that are in the numerator and the denominator. If we were just multiplying, we could. But because we have that subtraction sign in there, it has to be in every single term when we're adding and subtracting in order for us to cancel it out. So we can't just cross out the sine squared. But we do know that sine squared plus cosine squared equals 1. And we wrote down underneath that 1 minus sine squared is the same thing as cosine squared. So this is the part where the more familiar you are with those rules, the faster you're going to pick these things up. But anytime you see a sine squared, especially if there's an addition or subtraction sign anywhere involved, you should automatically start thinking about that sine squared plus cosine squared, because somehow it's probably going to be involved. So your hints for those Pythagorean identities are anytime it's squared and there's pluses or minuses. That's when we're going to start pulling those out. So I can change all of this to just be cosine squared. It's exactly the same thing because we have written down that 1 minus sine squared equals cosine squared. I think we actually have written down that sine squared minus 1 equals cosine squared, but I can flip those around and it's the same thing. So now I can rewrite this to just be cosine squared theta over sine squared theta. And now I've already got my function written as cosine and sine. So I don't want to change anything at this point, but I can simplify this to just be one trig function. I can simplify cosine over sine to just be cotangent. And since I have 2 cosines and I have 2 sines, it's really like saying I have cosine theta times cosine theta, right? It's the same thing as saying squared over sine theta and sine theta. And cosine over sine is really cotangent, so I really have cotangent theta times cotangent theta, which means I really have cotangent squared theta. So sometimes I'm going to get a pretty number like 1, and sometimes I'm just going to get it down to one trig function. All of the problems that you're doing today will either be one trig function, so you'll know you're done, or it'll be one pretty number, so you'll know you're done. Is this the craziest thing you've ever seen on a Friday? Yes? All right, let's work on your classwork together.